So share screen. Okay. Let me zoom in. All right, so actually I have that 10-4 from scratch. Hey, Philip. So, let me write with a pen. Hopefully it won't screw it up. But essentially, you have to, like, there's some of these, I think it's on, I want to say 10-3 or maybe 10-2, that says that, for example, e to the x, you can rewrite, man, that is really blurry. Hold on. Let's see what's better. All right. So it says that you should know this one, basically. There's a power series for e to the x, which is this, and it's x to the n over n factorial.
Okay, and we should just know that, like memorize it?
Yeah, you need to know this one, and you'll see on 10-5, you need to know this one, the cosine and the sine.
Okay.
Okay, so anyways, because of that, what they do first is they say e to the negative x, for example, will be the same thing as that sum I just wrote to you, except where they're gonna replace the x with a negative x to the n over n factorial like that.
Okay.
Does that make sense what I'm saying?
Yeah.
And then now, because the only thing they're missing is that x squared, they like, see, it's hard when you read the notes, especially for me, to know what they did first. So basically, they kind of come up with this, and then they multiply both sides times x squared. See, now I have the same thing as what I have here.
Okay.
You know what I'm saying? So now I have x squared e to the negative x is equal to now I guess I'll write it in steps. And this is the part that really sucks, is that it takes a really a long time to write all this stuff down. But essentially, you could write it like that. You see what I'm saying?
Okay, yeah.
What do they do from here? So here's the deal with this one. Because this is a power series, is very similar to a geometric series. So there's no need to test the endpoint. What do they want us to do? Really, and honestly, they simplify beyond what I just did. Oh, I see what they did. If you want to see what they did, they actually, anytime they have a negative being raised to the nth power, they basically get out a -1 and then just put that to the n. And then put x to the n, x squared, like that, over n factorial.
Okay.
Right here will be like by the powers, by the rules of exponents, I can rewrite this like this, right? I can add those two powers.
Yeah.
And that's how they come up with their answer. All right, now let me think about this. Now, because this is like, what else did they ask me for this? Okay. Because this is like a geometric or like a power series, they said that instead of doing all the ratio tests like we've done in the past, which I guess you still could. I mean, it should get you the same thing. But what they say on here, and I'll just show you what they wrote here because it's the same thing, what I'm about to write, is that this is the same thing. So they said that this part is like the ratio, if you will, of a geometric series. The geometric series, remember, looks like this. Okay.
Okay.
In a special case of that, or not, I'm sorry, this is a more special case, really, but the power series always, and then they kind of write, and this kind of leads into what I did, what I do on the next one. I think this is a over a minus r, I think. And then they're going to have something that looks like this, and this is what they call the power series. So you don't have to necessarily know all this right now, but you're gonna have to become really comfortable with this because it happens all the time. And honestly, that one on number 4, that's probably ones that it's not, because you're supposed to know e to the x. This one, it makes it not so tough. Like I was looking at, like, for example, like number 3. Number 3 would, in my opinion, would probably take me longer to do.
Yeah. I mean, you just kind of like I just factored out the x over 9. That way you
Right.
could get it to the formula of 1 over.
They're trying to force it into fitting something like this, which is what I just wrote. Right, so they're using that a lot. They're trying to fit it into this because this is a power series, which is this one right here.
Yeah, yeah, yeah.
Okay, so because of that, they want to make this a 1 and not a 1. So that's why they do all this crap like that, so you're able to fit it. But if you're able to fit it like that, notice that everything else it's pretty easy, because if you can fit it like this, it fits into this, and this x, which in your case is this part right here, becomes that. You see what I'm saying?
Yeah.
And then, I mean, the simplifying is kind of one of those things I have to really find out. Like if it was an AP exam, I'd probably just leave it alone. At worst, I might do something like this. The -1 to the end, I don't know. I need more experience with that. I feel like I've done it without doing that, and it's got me the wrong answer a couple of times. But anyways, I don't know that for sure. I need to really figure that out.
Okay.
But anyway, because if you can get it into this, and this part of the inside, this is the part that it has to be less than 1. So it's like a geometric series. The geometric series said that for something to converge, the ratio has to be less than 1. So that's why you keep seeing less than 1 and these keys like that, because that's the thing that's going to make it converge. And again, notice that because they are using this right here, which is a power series, and they actually this is a geometric series right here, but it's the same thing.
Okay.
Notice that they're doing that over and over again, because then they don't have to check the endpoints, which checking the endpoints kind of becomes like a kind of a pain, in my opinion.
Yeah, that was probably the hardest part, I thought, on 10.3 was just having to check the endpoints.
But anyways, as you can see here, like that's what they do here also. See what I'm saying? They just work out the problem where they have it in this form again, which is exactly like this form.
Okay.
If you can, then they can fit it into the power series, which is this one. You see what I'm saying?
Yeah.
Now, the thing that I didn't say, that I didn't really say anything wrong, and I do say it in 10.5, is that if you can get into the absolute value of x is less than some number, this right here, the 1/2, is the radius of convergence. You could, if you want to, still basically, how long is this interval between -1/2 and 1/2? That's 1, and then divide that by 2, and that's still the radius. So I didn't really lie to you. It's just like if you can get it into the x form like this, then that becomes your radius.
Okay.
So for example, even though they didn't ask for the interval of convergence, you could have written this like this. All right, so what's the distance between -3 and +3?
6.
Divide that by 2.
3.
So that's the radius.
Okay.
You know what I'm saying? So you can do it like that, like what I just said, or if you can get it into the x by itself, it can be x squared or anything like that. If it's x by itself is less than a number, then this number right here is the radius of convergence.
Okay.
Anything else from anyone, guys? Sorry, he got on there here early. He needs to get out early, so I'm recording this. So, it's only 8:36. So, anyone else?
Not really.
Okay. And again, Brock, and just to tell everybody, I have to really work through 10.4 just to put myself through the pain of this lesson. The recording the video was brutal. I hated it, but anyways, I think 10.5 gets a little easier.
Okay. I had a question. Could you do like one of them
on
from
10,
like 5 to 8? Like
on this?
on 10.4, yeah.
Yeah. 5 to 8. Okay, so I'm gonna just say a couple of things. Oh yeah. So here's the good thing about this, okay? as far as I can see, like 5, 7, and 8, you can use, you need to know, oh, hold on, I left the stove on. Oops. Okay. So on, let's see, 5, 7, and 8, you're gonna use one of the Taylor series that I told you should use. And again, this kind of comes down to, like for example, e to the x was x to the n over n factorial. Like for example, you're gonna use that. You could use that on number 7, I think. Let's see. Yeah, you can use that on 7 and 8.
Okay.
And then let's see, there's a sine. So there's one for sine. And again, I am just as uncomfortable with these because I don't have it memorized as you would be. But there is a sum for 10.5. Let me look it up here. Okay, I think is this. And again, please look it up because so a lot of the times when I was looking through their notes, sometimes I would have to literally go look at other videos because I was like, I have no idea where she got this from. But this is the one for sine. Whoop, I'm off screen. That's the one for sine. Does that make sense? So these are the ones you need to have at least handy. I mean, I wouldn't say memorize because really even your test is not going to be something you're going to have to memorize. Okay. And of course, you need the cosine one. And again, I don't know if that off the top of my head, so you're going to have to look that up. Let me see if there was one that has cosine on here. It's sine squared. No, again, I don't have that memorized, but I'm almost pretty sure it's the same thing except for, I'm going to attempt to write it, and then I'll look it up here in a second. Pretty sure it's almost like the sine, except it doesn't have the +1 on it. Okay, so again, please look this one up. I think this is right, but I could be wrong. Anyway, so for example, number 5, okay, and then once I do that, you're gonna know what they're doing. Okay, now I notice that on this one, they just want to find the Taylor series. So all I have to find is just the Taylor series. Okay, so it's the same thing as we've been doing, even on the past, even if they call it a, really this is a Maclaurin because it starts at 0, but anyway. So since I know the sine is what I wrote there, and this is probably why it was kind of confusing because they're just writing stuff assuming you know what they're talking about.
Yeah.
Okay, so you have sine is all of this crap. And also, that's what makes the notes extra long for me is that I have to write this every single step I'm going through. Right?
Yeah.
And then
you got multiplied by 1 over x, right?
Correct.
Okay.
So, okay. Now remember, we're integrating this.
Okay.
Okay, so, but the weird part is that we're only integrating with respect to x. Does that make sense? So what I'm saying here is that I will I will simplify this a little bit. If I divide this x to n plus 1 divided that by x, the 1s are going to cancel. I don't know if you see that or not, but they do. So basically, by the time I take the integral, or before I take the integral of it, that's what I would end up with right now. Again, I have to simplify this. I haven't done anything but just simplify this. Are you with me?
Yes.
And this is happened. I felt like I picked the easiest one, but
where'd the 1 over x go?
So the 1 over x went to here, right? I had kind of a side note. I had this x to the power of 2n plus 1, right? Mm-hmm. And the other crap doesn't matter. But the 1 over x, I can write it like this, right?
Yeah.
Well, this right here, if I rewrite it as x to the n times x to the first over x to the first.
Oh, okay. So then you just subtract. Okay.
Yeah, you can subtract the powers however you want to look at it, but the point is that you end up with x to the 2n, right? Yeah. You integrate. This is a constant, right? We're integrating with respect to x, right? So this doesn't matter and that doesn't matter. So
Okay.
I can actually just rewrite it like this. And now the only thing I'm integrating is this. I'm going to add 1 to the power, right? And then we're going to divide by that same power. And then this part right here stays the same.
Oh, okay. I got it.
And, oh, I forgot to write the sum. Son of a b on all of these.
I got it. Yeah.
And they write the plus c on this side, which is, it's fine. So that's that.
Okay.
Does that make sense?
Yeah, I got you.
So
All right.
on number 7, you're gonna do the same thing, just like kind of changing up the function enough times. Okay.
Okay. All right. I gotta head out. Thank you, Mr. Ochoa.
All right, man. We'll see you.
All right.
All right. Are all of you guys good?
Yeah.
Okay. Let me stop sharing and let me stop recording for a minute then.